Assalamualaikum, my name is Siti Arisha Hanani binti Syed Baharudin. My matrix number is 230632. Today I will demonstrate debugging an assembly program called average.asm. Now I'm starting from step 5, stepping through the program instruction by instruction to observe register and memory changes. First, I'm starting the debugger by going to debug right here and click on debug. The program is now paused at the first instruction of our main function. Next, I will open the memory window by going to debug and click on show memory. Now I need to add the variables. The first variable is data. The type is hexadecimal. Display as word. Array size 4. And the next variable is result. Data type hexadecimal. Display as word. Array size 1. Now you can see here in the memory window each value for the data and the result. Now I will open the register window by going to debug and click on show registers. This shows all CPU registers and their current values. Now I will start stepping through the program using debug step over. Just going to debug and click on step over. Starting at line 5, the instruction subtract EAX to EAX clears the EAX register to 0 by subtracting itself from itself. Before execution, EAX might contain any random value by system initialization, but after execution, EAX become 0 at 0. Now moving to line 6, move 0x04 to ECX, loads the value 4 into the ECX register. This sets up our loop counter and we will process 4 numbers. Let's step over, and as you can see, ECX changed from its previous value to 0x4. At line 7, move 0x08 to ESI sets the ESI register to 8. Since our data consists of 4 words, which is each 2 bytes, totaling 8 bytes, ESI initially points just beyond the last data element. So if we step over, ESI now become 0x8. Now we enter the loop at level AW for the first iteration. ECX is currently 0x4. At line 10, decrement ESI by 1, changing it from 0x8 to 0x7. As you can see right here, it has decrement by 1. At line 11, another decrement ESI decrements it again to 0x6. Let's step over, and you can see that it has decrement by 1 again. At line 12 is the core addition. The CPU calculates the memory address as the start of the data array plus the offset in ESI 6 and adds it to AX. Since AX is 0 at 0, so EAX now becomes 0 at 4000. At line 13, loop AW decrements ECX from 4 to 3. Because ECX is not 0, execution jumps back to level AW. Now, second loop iteration begins with ECX 0 at 3. Line 10 will decrement ESI to 0 at 5. Click on step over, become 0 at 5. Line 11 decrements it again to 0 adds 4. Click on step over and changes to 0 adds 4. Line 12 adds the word at the new offset. Now at offset 4, the memory contains 0 adds 3000. This value is added to A adds, currently 0 adds 4000, resulting in 0 adds 7000. Now line 13 decrements EC adds to 2 and loops back again. Third loop iteration starts with EC adds equal to 2. Now line 10 makes ESI became 0 adds 3. Line 11 makes it 0 adds 2. Line 12 assesses the word at offset 2, which is 0 adds 2000. Adding these two A adds 0 adds 7000 gives 0 adds 9000. Line 13 decrements is adds to 1 and loops back once more. Now, fourth and final loop iteration begins with EC adds equal to 1. Line 10 sets ESI to 0 adds 1 by stepping over it. Line 11 sets it to 0 at 0. Line 12 now reads from the very start of the data array at offset 0, getting the first value, 0 at 1000. Adding these to A at 0 at 9000 produces the final sum of 0 at A 000. Next, line 13 decrements ECS from 1 to 0. This time, because ECS has reached 0, the loop instruction does not jump back. Execution falls through the line 16. At line 16, subtraction EDX to EDX clears the EDX register to 0 adds 0. At line 17, move 0 at 04 to CX, loads the value 4 into the CX register. This sets the divisor for the average calculation. CX becomes 0 at 4. At line 18, divide CX performs division. A as A000 divided by 4 equals 0 x 2800 with no remainder. Therefore, AX becomes 0 x 2800 and the x becomes 0 x 0. At line 19, store the result from AX into the memory location labeled result. The memory window now shows the result variable, which was initially 0x0000, has been updated to 0x 2800. Line 21 and 22, prepare for and execute the program as it. Move 0x1 to EIX to 1, indicating the exit system call number. INT 0x80 triggers the system call, terminating the program. In summary, the program successfully iterated through the four numbers 0x1000, 0x2000, 0x3000, 0x4000, calculated their sum, which is 0x A000, computed the average by dividing by 4, which is 0x2800, and stored the final result in memory. Now for the bonus part, we have to stop the program first and we have to debug. Now I have added two new lines, which is this line and this line. Next, we have to click on step over until it reaches the print heads line. Okay, now we have reached the print heads line. Click on step over and you will get the output 2800. That's all from me. Thank you.